Hello and welcome to another video. If you don't know what derivatives are, I recommend checking the previous video about derivatives and the tangent line problem by Harry. But if you know it right now, we're going to go over two quick rules about derivatives today. So the first one is going to be the constant rule. And basically this is very simple. It states that for a constant function, the derivative will always be 0. So let's say for fx equals to c. Now we have a graph. Let's say it looks like this, and then c is here. So for fx equals to c, we want to say the derivative of fx will be 0 everywhere. So a simple proof will be by using the definition of a derivative. So limit of delta x going to 0, fx plus delta x minus fx over delta x, in fact, equals to limit of delta x going to 0. Now these are all functions of f, which is a constant function, so this will be c minus c for x, and then this is over delta x, and this is 0. So that's just a quick proof. And this rule actually isn't really powerful, and so we're going to introduce you to the second one, which is the power rule. And as the name suggests, well, it doesn't suggest it, but it is a very, very useful and powerful method that you can employ when deriving derivatives. So it says that for a function, fx equals to x to the power of n, d over dx, xn equals to n, xn minus 1. This is just another way to say that the derivative of fx is just n times n times x n minus 1. Now we could try this for some examples. Let's say n equals to 1. Now in this case, fx equals to 1, right? So the derivative will be, let's use the definition again, limit delta x going to 0, fx plus delta x minus fx over delta x. This will equal to limit delta x going to 0, delta x over delta x, because these are just the identity functions. Oh, I'm sorry. I'm so sorry. Fx equals to x in this case. That was a mistake in my writing. And this is 1. So does this apply to what the power rule states? So the power rule states that when n equals to 1, fx should equal to 1 times x to the power of 0, which is 1. And yes, correct. Now let's try for some harder examples. Let's say n equals to 2. So fx will equal to x squared. The derivative of fx, by the definition, will be limit delta x going to 0, fx plus delta x minus fx over delta x equals to limit of delta x going to 0. We can actually expand this. This is, oh, it's sinking again, minus x squared over delta x. This entire thing is just 2 delta x plus delta x squared. Whoa, why is it sinking so many times? Over delta x, which equals to 2x plus delta x. So this will be limit delta x going to 0, 2x plus delta x equals to 2x. Now, if we go back to the power rule, it states that fx should actually be equal to 2 times x to the 2 minus 1, which is 2x. And this is correct again. So here I'll give you guys a little exercise, and this is to see if the power rule applies when n equals to 3. You can pause the video right now if you want to try it out. Okay, we're back. Okay, so for when n equals to 3, right? Actually, the limit delta x going to 0, x plus delta x to the power of 3. You could do some algebra, and then you can note that this is, in fact, let me expand this, 3x squared delta x plus 3x delta x squared plus delta x cubed over delta x equals to 3x squared plus 3x delta x plus delta x squared. That's what we get after expanding. And so when delta x converges to 0, this will be 3x squared. And this still adheres to the power rule. So I hope that right now you're already convinced that this is true. But how do we know that this is true for all the positive integers? And furthermore, how do we know that this is true for any number n? So this, let me tell you guys a little secret. This is actually true for, oh, I'm not going to write this. This is true for any rational. I think it's actually for any real n. It's true for any real n. Yep. And it doesn't care if it's positive, negative, rational, or irrational. This power rule will always be true, which is hence why it is so powerful. Now, right now, we're going to give a proof for why this holds for a positive integer. So for a positive integer, right, fx equals to x to the power of n. I'm going to zoom in a bit. The derivative of x will equal to limit delta x to 0, fx plus delta x minus fx over delta x equals to limit delta x going to 0, x plus delta x to the power of n minus delta x to the power of n over delta x. Okay, now we should probably expand this right now. If you guys don't know what binomial expansion is, I recommend going on a website such as The Art of Problem Solving, or just Googling it to see what it is. But we're going to use this right now. This will equal to x to the power of n plus n x n minus 1 times delta x plus n choose 2 x, whoa. Sorry about that. X n minus 2 times delta x squared plus dot plus delta x to the power, oh, I'm sorry. This part should be just x plus delta x to the power of n minus xn, this entire thing, this entire thing over delta x. So this is in fact equal to n times x n minus 1 plus n over 2 x n minus 2 times delta x plus a bunch of things. But what do we know about this bunch of things? This bunch of things are all a multiple, oh my god, my Wi-Fi. This is all a multiple of delta x. So when delta x converges to 0, we cancel all of this. So the derivative is, as the power rule states, n times x to the power of n minus 1. And this is the key thing about today's video. Thank you very much.